Hello, everyone. Welcome and thanks for joining us today for our webinar, Establishing an Equipotential Zone for Increased Protection. My name is Marissa Davis. I'm Marketing and Communications Manager at MPK, and I'll be facilitating today's presentation. The host of today's presentation, NPK, provides temporary access roads and worksite pads to facilitate work in challenging terrains. NPK is the only site access solutions partner to manufacture and rent industry-leading sustainable composite matting, along with a full suite of services, including planning, logistics, and remediation, so you can protect your people, the environment, and your bottom line. To learn more about our products and services, please visit our website at www.npki.com. Now let me introduce you to our presenter today. Adam Marcel is our Technical Sales and Business Development Manager here at NPK. He's been with us for about 6 years now and works out of our Karen Crow, Louisiana facility. Adam earned both the Bachelor's of Science in Civil Engineering with a focus in Structural Engineering and a Master's of Business Administration and Project Management from Louisiana State University. Adam has over 10 years of experience in the oil and gas industry and related engineering fields of design, reliability, mechanical and applicational testing, and he is our subject matter on all things DURA-BASE. Thanks for joining us, and with that, I'll turn it over to you, Adam.
Here's an agenda that we'll cover today. This presentation will mainly give you technical basics, describing the fundamentals of an equipotential zone and when one may be needed to protect workers on a job site. So I'll also outline the industry standards that can provide guidance in creating an equipotential zone, how it should function during use, and the associated requirements needed to ensure safe working results. And then finally, I'll demonstrate how DURA-BASE EPZ Grounding System fits these requirements and how this product can easily fit into your electrical project operations. We won't take any questions today, but I will give you my contact information. Feel free to reach out to me via phone call or email if you have any questions following this webinar. So we'll first start off with describing the industry in which electrical energy is transported. Power line utilities, including electrical generation stations, transmission and distribution lines, electrical substations, and step-up or step-down transformers all carry massive amounts of voltage or potential energy to consumers. Transmission lines can be thought of as the interstate highways of electrical delivery. They carry the bulk of the electricity from generation stations over long distances to areas of demand. Typically, these are the large tower structures that can be seen running through open fields, wide valleys, or even swamplands, and they carry potential energy of 100,000 volts or more. On the other hand, distribution lines can be considered the city streets of electrical delivery. These are the smaller lines that are seen running from a substation along busy streets near neighborhoods and stores. These lines deliver energy to power homes and businesses and can typically store upwards of 40,000 volts. This potential energy, referred to as voltage, pushes charged particles through conductive lines to produce a flow called electrical current. Current can only travel when there is a difference in voltage from point A to point B, as depicted in the bottom right illustration. To most people, electricity is a phenomenon that is kind of hard to comprehend because it can rarely be seen. Lightning is a natural example of electricity. Electrons are pushed from a high potential thunderstorm cloud and travel through the air to a conductive medium that dissipates the charges into the low potential ground. These electrical properties have been harnessed through science and physics, allowing us to control electrical energy to power our household appliances, lights, and computers. When working in the electrical utility industry, it's important to understand the fundamental principles of electricity. This includes Ohm's law. Ohm's law defines the correlation between voltage, current, and resistance. You can think of voltage like a pressure. It is the motive force that creates a potential for electrons to move. When there's a difference in voltage between 2 points, electrons can flow, referred to as current. Depending on the conductive medium that the current is flowing through, there will always be some opposition or resistance to that flow of particles. The amount of resistance is mainly driven by the material, the size, and the distance of the particles that they're having. Understanding that the amount of current flowing through a conductor is dictated by the voltage differential and the resistance of that conductor will provide valuable appreciation to safely work around electricity. Have you ever thought about how much current is running through our wires in our household walls? You know, a very small electrical current between 1 and 5 milliamps can be felt by the human body as a slight shock, and it may only temporarily cause some pain. Whereas another small current of 30 to 150 milliamps can cause muscular control loss and respiratory paralysis. If you were to open your breaker box in your home and you would see the circuit breakers that read 15, 20, 30, or even 60 amps, this is describing the amount of current it would take to switch open that breaker, preventing damage to that electrical conductor due to a possible overcurrent event. If this amount of current was pushed through our bodies, which is thousands of milliamps, death is probable. The amount of voltage associated with our household current is only 120 to 240 volts, common for most appliances. In the electrical energy industry, transmission and distribution lines experiencing thousands of volts can carry hundreds of amperes in current. Knowing how to safely work with these hazards can actually preserve your life. Circuits are the conductive path for the transmission of energy. So energy enters from one or more sources and exits via one or more sinks. There are various types of circuits, each routing energy in a unique configuration. Today we'll talk about parallel circuits. Parallel circuits are key to our everyday lives. They supply reliable power to many complex systems and allow individual parts to function even if there is a disruption within the system. The key to a parallel circuit is that the voltage is the same across each junction. This allows for different currents to travel to each component within the circuit. As an example, you can see the parallel circuit illustrated in the bottom right. It shows that nodes 1, 2, 3, and 4 are at the same electrical potential, or they're at the same voltage. And therefore, there is no net current difference at each of those points. The current traveling through each of those resistors will be reliant upon the resistance of each branch. So the philosophy will be essential in establishing an equal potential zone. So now we've gone over some principles of understanding the fundamentals of Ohm's law and what electricity is. What is an equipotential zone and why is one needed? Well, according to OSHA, the Occupational Safety and Health Administration, an equipotential zone, usually abbreviated EPZ, is a work zone in which workers are protected from electrical shock due to differences in electrical potential. These differences in potential can be caused by induced voltage, line re-energization, or lightning. OSHA goes on to state that the workers in an equipotential zone is protected from electrical shock because there is a near identical state of electrical potential between any 2 points on the body. So in other words, OSHA is expressing that any 2 points of conductive objects on the work site or any 2 points on a worker's body must be at equal potential or equal voltage, which is indicative of these objects being in parallel to the main source of voltage. For the safety and well-being of all employees, establishing an equipotential zone can be found in 2 sections of the OSHA standards. The first is within the 1910 General Industry Standards under subpart R. Specialty industries, the electrical power generation, transmission, and distribution standard. This covers the operation and maintenance of electrical power generation, control, transformation, transmission, and distribution lines and equipment. The second OSHA standard governing equipotential zones can be found in the construction standards under subpart V in electrical power transmission and distribution, specifically when it comes to the construction of grounding for the protection of employees. Each of these standards describe how an equipotential zone can protect workers from electrical hazards while working in our power utility industry. In addition to the Occupational Safety and Health Administration, another organization, IEEE, or the Institute of Electrical and Electronics Engineers, is another valuable source that builds the best practices for the electrical industry. The IEEE organization fosters a collaborative environment that is built upon over 427,000 members in more than 190 countries. These industry experts consist of engineers, scientists, and allied professionals whose technical interests are rooted in electrical and computer sciences, engineering, and other related disciplines. Their drive is to discover the most functional and capable products and services to lead and develop international standards across telecommunication, information technology, and power generation products and services. They have a database of over 2,000 active and developing documents, which cover recommended practices for the selection, testing, application, installation or maintenance, and the life expectancy of electrical equipment. Specifically within IEEE, there's guidance that describes when an equipotential zone should be used and how to construct one. In IEEE 1048 standard on the guide for protective grounding of power lines, it suggests several practices, technical information, and safety criteria for temporary protective grounding. Within this standard, there is further guidance specifying material that an equipotential zone should be constructed with. This standard is currently going through an amendment. The IEEE P1048B will state that the use of a rigid carrier mat meeting the requirements of ASTM 2715-19 testing should be utilized when establishing equipotential zone of workers. So as we'll see later in this presentation, the DURA-BASE EPZ Grounding System meets these requirements according to this standard. Fully integrated EPZ grounding systems patented technology provides an advanced solution for creating equipotential zones. Expanding upon the benefits of the DURA-BASE advanced composite matting system, a conductive grating secured to the mat creates a continuous platform of electrical potential. Rated connector bonding straps and electrical collection devices such as bus bars help the system integrate multiple mats together, providing a consistent working environment that increases worker safety. So this mat comes directly from our manufacturing plant, ready to be installed in remote field applications during potentially hazardous de-energized operations. With a standard 18-wheeler truckload of EPZ mats, you can easily create an equipotential zone of over 3,000 square feet in minutes. The DURA-BASE matting system can provide access or staging areas that lead to a custom Equipotential zone configuration, all atop poor soil conditions and hard to get to maintenance areas. This system provides multiple options for grounding, protection from touch and step potential, and can incorporate with our OSHA certified barrier system fencing to prevent unauthorized entry. The key benefits of the DURA-BASE EPZ system includes its pre-assembled format, rapid installation, and its compliance to the ASTM standards, all making this product an essential component to many electrical projects. Now that we know the primary principles of electricity and have been introduced to NPK's DURA-BASE EPZ system, how exactly does it work? Just as the fundamentals of a parallel circuit were described earlier, the equipotential zone shall establish a secondary circuit in parallel with the power source. It shall also provide an uninterrupted conductive surface that routes accidentally energized current to a safe objective for dissipation, or to the ground. In the words of OSHA, temporary grounds and bonds should be installed in such a manner that keeps the work site at the same potential energy to prevent harm to workers, even if the line is accidentally re-energized or exposed to induced voltages. A working equipotential zone should never be the primary path for high voltage to be grounded. This working area should be a secondary means to ground for any residual current, and all equipment should be de-energized. In order to be a part of the circuit, all conductive components, including workers, shall be connected to the EPZ surface, acting as a node of equal electrical potential. If the circuitry is not properly established according to industry standards in the installation and handling manual, dangerous conditions may emerge. Once the project scope has been defined and industry standards call for electrical protection of worker, NPK can provide its products and services to safely streamline the operation. Does your project need access and installation of matting products? Our operational crews can work with you to analyze the job site and provide a best fit custom solution, with also installation and demobilization services of the DURA-BASE and EPZ matting platforms. Customers who own their own inventory of DURA-BASE EPZ mats can follow NPK's installation and handling manual to construct a reliable work site that meets industry standards and local requirements. Once the mats are in place and electrical components are arranged, on-site testing can be easily conducted with an ohm meter to ensure continuity throughout the system and low resistivity to the dissipation devices. All electrical components of the DURA-BASE EPZ grounding system, as well as any conductive equipment on site, should be securely configured and installed by competent and properly trained, licensed and qualified personnel who are fully knowledgeable on circuitry and protective grounds. NPK can provide technical specifications on its manufactured products, but is not certified to connect and configure the electrical components of the system. No electrical work should begin until the equipotential zone has been verified in accordance with the safety requirements and technical standards outlined in the manual. Active and periodic inspection and maintenance of all EPZ components should be performed throughout the duration of the project to ensure ongoing performance of the system. When constructing according to the guide, NPK's products and services focus on maintaining the safety of worker personnel as the top priority during project operations. To ensure our products can operate to a high level of performance,
NPK spends research and development efforts testing products against international industry standards. The American Society for Testing and Materials International is a global leader in developing and delivering over 12,000 standards to improve product quality, enhance health and safety, strengthen market access and trade, all while building customer confidence. The members who work together to create test methods, specifications, classifications, and guides that support industries and government worldwide. Specifically, the F-18 Committee on Electrical Protective Equipment for Workers focuses on the implementation of tools, materials, and equipment to be used by workers for the protection from electrical hazards. Within the subcommittee governing mechanical apparatuses, there's a standard specification for temporary protective equipotential bond mat to be used on de-energized equipment, standard F2715-19. In this standard, an equipotential grounding system, defined as a temporary grounding system placed in such locations and arranged in such a manner as to minimize the likelihood of workers being exposed to hazardous differences in electrical potential, must meet chemical physical requirements, including dimensions, workmanship, manufacturing, as well as must pass specific electrical testing. There are 4 parts to the electrical testing within this specification, and all testing was conducted in a single and cascaded mat configuration. The first study consists of a resistance test. Using a micro-ohm meter, current is injected through the mat to measure the voltage drop across various points of interest. The results must be below 1 micro-ohm per foot, and this test should be conducted before and after every other test to ensure low resistivity and good electrical continuity. The next study consists of a continuous current of 250 amps running through the matting configuration while measuring temperature at various points. Requirements indicate that the conductive surface should not exceed the temperature of the lug connection or a maximum of 167 degrees Fahrenheit or 75 degrees Celsius, demonstrating the material to maintain a safe electrical performance. The third study tests the structural integrity of the conductive surface by applying a short circuit current through the sample. No evidence or observation of arcing, sparking, or visible damage should be noted to the mats once the test is complete. Again, a resistance test is to be conducted afterwards to ensure electrical damage did not occur. Lastly, the EPZ mat is configured in a parallel circuitry loop for a design test. A 1 kilo ohm resistor connected to the supply bus is also connected to a steel plate that sits atop the conductive surface. The supply bus is also connected to the EPZ mat with a lead running to the return bus, acting as a ground. 8,000 volts are applied to the circuit, and a measurement of less than 5 volts and 5 milliamps must be read across the resistor. The DURA-BASE EPZ mat excelled in all aspects of these testing, both as a single and cascaded assembly, therefore providing evidence of a robust, temporary protective equipotential bond mat meeting these industry standards. In connection with the EPZ system, NPK has also developed a safety barrier fencing system that fully integrates with the DURA-BASE mat. Enclosing your worksite with a barrier is a common safety practice to keep unauthorized personnel out of danger. Many electrical hazardous areas require some sort of protection, such as fencing and signs that inform nearby workers of the dangerous conditions. The specific material chosen to design this railing system is also non-conductive, which aids in the equipotential zone's effectiveness for worker safety. Not only can the system be customized to the matting configuration, but it also has been certified to OSHA guardrail systems. According to the regulations for construction, employers shall provide and install fall protection systems where applicable. Testing has been conducted by a third-party laboratory to endorse NPK safety barrier fencing in accordance with OSHA standards. The results of the experiment showed that the system is capable of withstanding, without failure, a force greater than 200 pounds in an outward or downward direction. In addition to the testing, the dimensions and setup of the railing system allow all parts to meet this 1926.502 standards. This preferred method of railing does not rely on workers to be trained to use, inspect, or wear fall protection systems when in place. If a fall protection area is not needed, this system can convert into custom fencing connected to the matted site for the scope of the project. One application where the DURA-BASE EPZ grounding system serves as a reliable safety device is during substation maintenance, specifically for mobile or temporary electrical substations. The power sources of a mobile or temporary substation may be continuously energized. In the event that the substation is compromised, a primary path to ground will typically be established through a bushing. All conductive components associated with the substation shall also be connected in parallel to an equipotential zone, thus creating a secondary circuit for any residual energy. This secondary circuit, which also includes the DURA-BASE EPZ grounding system, allows all connected components to be subjected to the same voltage or equal potential energy, keeping workers within the system safe. Planning, coordination, and execution of this site layout is key to the overall safety objective of the project. Another common application for the DURA-BASE EPZ grounding system is the power utility line streaming operations. During this activity, the conductive lines may be live or become accidentally energized due to induced voltage or electromagnetic fields. Creating a secondary path to ground with an equipotential zone will surely aid in the safe operation efforts of the workers on site. Equipotential zones can be as large as needed to accommodate all equipment and accessories that will be needed for the duration of the project. The DURA-BASE mat, acting as the carrier component of the EPZ system, helps to provide a stable platform in remote areas of subpar soil conditions. NPK's access and site solutions can help protect your people, protect your project's timeline, protect your assets, while all at the same time protecting the environment. Thank you again for attending and listening to our webinar on the DURA-BASE Equipotential Zone Grounding System. Feel free to reach out to me via email or phone. Call for any technical support you may need with your projects.
All right, thank you, Adam. And that's all the time we have for today. We hope you've all enjoyed the presentation. Have a great rest of your day. Again, thanks for joining, and we'll see you next time.